Hi, welcome to my channel. Today we're going to talk about the linked list. We use a linked list to store a sequence of objects which consist of nodes. Each node has two parts, a value and the address of the next node in the list. These nodes are linked together. We refer to the first node as the head and the last node as the tail. Runtime complexity, lookup by value, big O of n, by address, big O of n. Insert at the end, big O of 1, at the beginning, big O of 1, in the middle, big O of n, which is finding the item, then updating the list. Delete from the beginning, big O of 1, from the end, big O of n, from the middle, big O of n. A linked list is one of the fundamental data structures that you need to master. Let's build a linked list together. This C# class represents a basic implementation of a singly linked list. Let's break down the key components and methods. Node class. Node class represents an element in the linked list. We only need the node class inside the linked list and we don't want outside access to it, so we define it as private. The node class contains an integer value and a reference to the next node, which is nested inside the linked list class, making it private and encapsulated. Linked list class. Linked list class maintains a reference to the first and last nodes. Utilizes a private node class to structure the linked list. Methods. These are the essential methods required in a linked list. We start with the add first. Add first int item adds a new node with the specified value at the beginning of the list. Here we're defining a new node. We're passing the item, the value to it. If the list is empty, if first is equal to null, then the node will be our only item in the list, and we put node in the last and first. So the all last and first will refer to this node. Else, if you have other items in the list, and we want to add the node as the first, then we put node.next first. And we put node in the first. Basically, from now on, first will refer to this new node. Add last. Add last int item adds a new node with the specified value at the end of the list. Here we're defining a new node. We're passing the item value to it. If the list is empty, then first will be equal to last equal to this new node. Else, since we want to add it at the end of the list, then the last dot next will be this new node. And our last will be this node, so we put the node in the last. And last pointer will point to this basically new node. The next method is remove first. Before going to the next method, let's go over to the isEmpty helper. IsEmpty is a helper that is a type of Boolean, and it's checking here a condition. If first is equal to null, that means the list is empty, so we'll return true for us. If first is not null, then we have items in the list, so it returns false. Let's go back to where we were. So it was part of the add last method. And the next method is delete first or remove first, which removes the first node from the list. Here we have edge cases. One of them is if the list is empty, then return. So because there's nothing we can remove. Another edge case is if first is equal to last and we want to remove first, then all we need to do is to put first equal to last equal to null and return. The type of the method is void, so we can just return here. Imagine the list as this. This is our linked list starting from 10, pointing to 20, and pointing to 30, the last item. Right now, first is pointing to 10, but by removing the first, then the first will point to 20. And this will be our final result, 20 pointing to 30. Here we need two new references, first and second. We keep 20 somewhere. We keep the second item of the list somewhere. So we define a variable called second. First.next will be in the second. And we put first.next, which is 10 right now. We put the next of this one null. Remove the first item by removing the link between 10 and 20. So when we remove the link between 10 and 20, we basically are removing the first item from the list. And then after that, we point the first to the second item. So we put the second to the first. Now the first is referring to the second item as the first, basically, which this will happen. The next method would be remove last or delete last, which removes the last node from the list. Here's our list, 10, 20, 30. Our last item is 30, and we want to remove the last one. We traverse this list from the beginning, and when we reach the item just before the last one, when we reach 20, we keep a reference to that node for updating the last item. Here we're checking the edge cases first. Empty list. If it's empty, to an exception, there's nothing we can remove. And another edge case, if we have single item, if last is equal to first, then for removing the last, we just need to put last equal to first equal to null and then return from here. Else, if we have other items in the list, if we have more than one item basically, then we go to the next part of the code, which we get the previous of last. Previous of last is 20. We put it inside a variable called previous node. And when we got the previous to the last, then we point the last to this previous node. Then that will make it our last node. And we put the last.next equal to null. Last.next, right now our last is 20. If we put last.next to null, then it's not pointing to 30 anymore. Then it will be just our list will be 10 and 20. And let's check to see what is the getPrevious method helper. The getPrevious, we're passing a node to it, and we start from the first. In the linked list, we have our first node. We put the first node to the current node, and we loop through our nodes. We say why current node is not null. Then if current node.next is equal to this node, then return the current node for us. This way, we get a node before this node that we're passing to the getPrevious one. Else, we move one forward. So we put current node.next into the current node. And we do this while loop until we find the node before this one. If we couldn't find it, then we just return null. Let's go back to where it's being used. So it was being used in the remove last. The next method would be contains. Contains int item checks if the list contains a node with the given value. In order for that, we have to traverse the whole list to see if we have this item in the list or not. So we start from the first, we define a node, we name it current node, and we loop through the list. We say while current node is not equal to null, if current node.value is equal to this item, then return true. If not, move forward, current node.next, put it in the current node, and loop through it until we find this value. If we got to this far, it means the item does not exist in the list, so we return false. The next method is index of. Index of int item returns the index of the first occurrence of the specified value in the list. First, we initialize index to 0, and then we start from the first, we put it in the current node, and we loop through the list while current node is not null. If current node.value is equal to the item, then we return the index of that. That means we found the item, so return its index. If not, we move forward, we put current node.next into the current node, we add 1 to the index, and we do this loop until we find the item. If we couldn't find it and we got to this far, then that means the item does not exist in the list, so we cannot return its index. Instead, we'll return -1. The next method called size. Size returns the number of nodes in the list. If the list is empty, we have no item in the list, we return 0. If first is equal to last, that means we only have one item, return 1. Else, continue. Basically, we put first in a node called current node. So far, the size is 1. While current node.next is not null, then we move forward. We put current node.next inside our current node and we add 1 to our size. We do this for loop until we get to the end of the linked list. At the end, we return the size. The next method is toArray. ToArray converts the linked list to an array of integers. We define a variable, which is type of array of integer, new int. We have to pass the size because arrays are fixed size. So we need to define from the beginning what is the size of the array we're defining. And we find the size by the size method we have. And after that, we put the first dot value into the current value. And we put first dot next into the next node. The current value, we can put it into the array 0, which is the value of the first item in the list. And we can have a for loop starting from 1 because we already got the item at the index 0. And then we're starting from 1, we go to the end of the list, which is the size of the linked list. And we put next node, which right now is the node after the first one, dot value into array I, and we keep moving forward. We put next node dot next into the next node, and we have this for loop until we get to the end of the list. This way, we put all items in the array, and at the end, we return the array. We already checked the is empty, and we checked the get previous as well. We also check the size, that how we can get the size of the array. So these were the important methods in linked list, and this implementation provides a foundation for working with the linked list in C#, offering methods for adding, removing, searching, and obtaining information about the linked list. Hope you enjoyed this video. Thank you.